Hello everyone, hope you all are doing very well. We all know that the success of any deep learning projects depend on several factors. Everything starts from the good and ample amount of data, then your training strategy. Once model is deployed, that is not the end of the project. You still need to monitor it to make sure your model is performant. Based on my experience, where I have developed various data and machine learning platforms for larger enterprise, I am going to share you these 10 steps to ensure significant amount of success for your deep learning projects. Whether your deep learning project is big or small, complex or simple, these 10 steps is definitely going to help you to successfully complete your deep learning project. Not only make sure the problem you are solving with the deep learning methods is going to be helpful, and you are going to have a solution which is going to be directly applicable to the problem. So let's get these 10 points understood correctly with regard to a successful deep learning project. The first and foremost important aspect to solve a particular deep learning problem is to first understand it and then define it. No matter how complex the problem is at the start, however, if you spend good enough time to understand it correctly and clearly, you can make it simple to solve. Each deep learning problem is divided into so many small problems. Within those problems, however, the objective of all of these problems is going to be the single to solve this problem as a larger subset. So you have to not only clearly understand and define the problem, you must know what is your final objective. Without achieving or without defining your final objective at the last, you will not be able to solve the problem, because the solution is actually the stop, because the final solution is actually the step of very small solution. So if you know what is your higher or the larger objective at the last, you will not be able to break down that problem into multiple small subset of the problems, and you are going to solve each problem in each small step, and the culmination or the combination of the solution will be your final larger solution. After you have understood your problem better, now the second step is to prepare your data. Data is everything. Your data is required to solve the problem, not to create the problem. It means you have to prepare your data. The data you have at the start may or may not be applicable or valuable for any deep learning problem. You need to prepare, means you need to make that data ready for the deep learning problem. And there is a lot to talk, there is a lot to learn in this step. However, it is very important for you to make sure that your data is your project ready. It can be applied to the deep learning problem which you are going to solve in your project. The data you have which is going to be applied to this problem must be clean, must be validated depending on your problem, and it should be appropriate to solve that problem. For your problem to be successfully solved, you must be able to gather as much as data which is relevant to your project, clean it, prepare it, and make it machine learning or the deep learning ready specific to your problem, because this step is going to be the very first guarantee to achieve a rightful solution to your deep learning problem. Once you know that your data is ready, the third step is to choose the right approach. Your right approach is a method which is depend on the type of problem you are solving, the type of solution you are going to achieve at the last, and the data you have prepared for your problem. It is very much certain that at first you may not have the right approach. However, you need something significant to start with. And as you iterate, you will have the best approach which is applicable to the given problem you are working on. If your data is not labeled correctly, however, you are going to venture into a problem, then you might be choosing a different analysis method at the start so that you can add more labels to your data. It means you can add more training data to solve your problem in a larger context. So the previous ways to solve a natural language problem may not be applicable to you because now the transformers can be used to solve your problem. So, however, is the transformers based network is the proper approach to solve your problem? That has to be understood through experiments, and that is very important for you to choose. Once you selected a method, whether you want to use the transformers or you would want to use the RNN based architecture or you want to use the CNN or you are just trying to create a neural network which is hand coded by yourself in any of these different network type, it is important for you to have some kind of baseline understanding that using a particular method is going to give you a certain results, and that will be your guiding step in order to achieve the right approach. At least when you think that you have a right or a starting method to get you started, the next step is to choose the baseline approach. The baseline approach is a combination of step 3 and this step 4 because that is going to give you the next step. In the baseline approach, whatever the method you have decided, you take a subset of data or the full set of data and apply to this method. If you decided you are going to use the transformer, use the collection of data you have and apply very quickly with the transformer to get the subset of a solution in your larger context. The pre-trained model which you have decided to use for that purpose, give a quick test and see that what are your baseline results. And if you have achieved the right approach or the semi-right approach and your baseline results are encouraging and they are giving you confidence that the combination of strategy and baseline approach is good, that is going to give you the step number 5, choosing the best or the appropriate network which is going to solve your problem. As we know that the neural networks are basically a collection of neurons and the layers. And to train your model which fits your particular data specific to your problem, you need the right architecture, right network architecture, or the right neural network architecture. And at this point, your experience working on many problems is going to help you because you can find these models at so many places. You can find these models available at Kaggle. You can also find the Hugging Face repo. Not only that, the TensorFlow as well as the PyTorch libraries, there is a collection of models specific to these deep learning libraries. Not only that, there are model zoos available where you can find the interoperable deep learning models, means you can take model from one language instance and convert it into in another language depending on your requirement or your particular network architecture need. So there is a lots of things you can do, and it's all depend on how much experience you have while working on the real problems which help you gain these tribal knowledge which are only available while working on the real complex real world problems. And at this step, we can go one more level back where we think about where we thought about using the baseline approach. That's where you can actually use these pre-trained models which are available at the Hugging Face or the TensorFlow Hub or the PyTorch Hub, and download these models which are basically the pre-trained weight, and then you can add more layer or more network depending on your problem, and then you can very quickly come up with the baseline results. So once you have at least got semi-success to set up or configure your training architecture, the next step for you is to set up a training methodology. Your training methodology or your training strategy is very important. And I would say this is the time or this is the place where you are really going to use your expertise in a particular deep learning engine or deep learning library, because depending on which library you choose and the network you have chosen, your path may vary. So the training infrastructure is very important depending on the network you have chosen and the size of data you have. Now these days you can actually use the Hugging Face as well. There are several new players are also coming into the market which can take a particular kind of problem and train depending on the network you have chosen. And within the training strategy, the another technical aspect is the hyperparameter tuning or hyperparameter optimization. Your neural network is a combination of lots of layers, and each layer has a significant amount of properties to be set correctly in order to get the best results. Sometimes you have to experiment the proper parameter values, and in order to achieve the fit parameter value, you have to perform a series of combinations to get what you are looking for, and that process is hyperparameter optimization or the hyperparameter training. You need really very good code logic which actually look the certain values which can be applicable to the given network you have, and based on the best hyperparameter optimization and the tuning strategy, you are going to get the machine learning training achieved at a point where the results are going to be used down the road or the downstream business logic. That's why you are solving this problem and the training your deep learning model. And at last, the training strategy also involve for you to build your model and the test your model. There should be a way where you know that how you are going to test your model once it is completed. Depending on what is your training mechanism, whether it's a fully online or online offline, it could be a hybrid model, you can come up with the best validation strategy for you to test and validate your model. And once we start talking about the testing and validation of the model, that's where we go to step number 7, which means how you can avoid overfitting through the regularization. Reason I put this step as its own independent step because sometimes it is very important for any deep learning or any machine learning problem to make sure that your model is not learning or not memorizing the training data. It means you need to regularize your model. People say, oh, is your model is regularizing properly? It means it's not overfitting, and it means that it is not memorizing. If your model is overfitting, it means it's going to work best on your training data, but as soon as it sees the test or the real world data, it will fail to predict correctly. And in order to achieve the higher regularization in your model, your training strategy has to be very good. It means you have a very good combination of hyperparameters which are helping your model to learn better. In order to achieve higher regularization in your deep learning model, it is important for you to make sure that you have a very good combination of hyperparameters and you have a very good split in your training and the validation data so that your model is training far better. However, sometimes these methods are not enough. And that's where step number 8 comes, and that is the enhancement through the augmentation. And reason I gave this step as an independent step, not combining it with the hyperparameter uh, tuning or the regularization, I made sure because the success of your product is depending on how good your model is, and it is very important for you that you know a collection of data augmentation, hyperparameter augmentation, the network augmentation techniques where you can leverage these treasure trove of the information which is available outside to enhance your model performance. Sometimes you can use data augmentation to generate newer data. It means you have a lot more data for your model to learn from. You can also add the third-party data set depending on your problem, whether you are solving the transactional data or you are working on document or unstructured data. You can use the data augmentation techniques to augment your data, which will help you to learn better. Not only that, there are various augmentation methods for the hyperparameter training, which the built-in libraries, depending on your network or the engine or the deep learning engine you are using, you can apply in order to achieve the higher regularization in your model, which will enhance the overall performance of your deep learning model. Once you know that the model you have built is good enough and it can be used for the business problem you are trying to solve in your deep learning project, it is the time for you to make sure that you have model interpretability added into your deep learning project. The model interpretability is very important because it takes the black box or the unexplainability which is available in your model when your model is predicting the results. Instead, with these interpretability or the explainability component available in your model, the model results are explained to the common people in the language which they could understand. By adding various interpretability as well as the explainability methods or methodologies in your model, you can make your model more applicable to the business where you are going to apply the model. The explainability can go very deep. They can be applicable to your model, or they can go even more deeper and they can look into the training infrastructure as well as the inference infrastructure to make sure that the explainability which is required in order to use your model or in order to consume your model in the business setting, that is applicable, or that's all depend on how much explainability you really need in order to make sure that model is available or model is usable to the business problem you are working on. Last but not least is our 10th step, which is the monitoring your model after its deployment. Means deploy your model and monitor it. And deployment is going to be only occur when you know that your model is successful, applicable to the problem you are working on, and it is ready to go. Your model can be used for real-time inference or it can be used for batch inference. Sometimes in real-time environment, your model has to provide inference or the predictions at sub-millisecond level. So the infrastructure where you are going to deploy your model has to be capable enough to fulfill the need of your model inference. Sometimes you might need to deploy your model to the endpoint. It means you need to make sure that your model size is smart or the small enough where it can work on the edge. So, and it is important for you that you have a very good strategy available to make sure your model deployment is complete and fit depending on what kind of inference results the organization is looking for. After model is deployed, you have to monitor, because you need to monitor so you know that your model performance is not decaying. Based on real world problems, everybody have seen that over time the model performance decay. And as soon as you see that model is decaying or model performance decaying, you need to know what is the threshold where this model will not be usable to the problem you are working on. So you need to retrain it. Retrain goes back to square one, where you need to make sure that you do have a very good retrain pipeline built into, which is going to retrain your model by adding the newer data which your model has been used for inference, and combining the previous trained data and the newer data, you can retrain your model and apply all these steps which we have talked about in order to build the newer model and then deploy and then keep monitoring. It means this work never stops. However, if you use these 10 steps available for you, I can assure you that you are going to complete your deep learning project not only successfully, but also you are going to be very successful reiterating this method to multiple time or the multiple time on the same problem or the different problems. There is a lot can be added to the content which I have provided. However, I do believe that if you follow these 10 steps, you are going to achieve significant success on your deep learning problem. That's all I have for you in this video. I do appreciate your time, and I'm looking forward to seeing you in my next video. Until then, thank you so much.